Right guys, we are on page 136, numerical methods. And this is all about finding roots. Roots would be where the curve crosses the x-axis. The x-axis is where y would equal 0. So essentially they're saying, if this is y equals f of x, they're saying when is f of x equal to 0? We only look for where you've got a continuous function. Okay, and what that means is where there's no breaks in the curve. So for example, if I drew y equals 1 over x, that has a break. Can you see it's not continuous? There's a break there. So that is a discontinuous curve, whilst this is a continuous curve. Okay, and if we're looking for roots, usually we solve it algebraically. So for example, if I had a quadratic like that, and I was trying to find where it equals 0, you could solve it on your calculator, you could do it by hand, but you'd get two solutions. In this case, I think it is -1 and -4. No, x minus 1 times x minus 4 is the factorization, so x would equal 1 and 4. Okay, so that's how you would do it algebraically. Now, some functions you can't solve algebraically. It might be that you don't know the method, or there is no method to solve that particular algebraic expression and when you put it equal to 0. So what you need to do is look for a sign change. So here you can see at this point f of x equals 0. Now I've got two x values. I've got x equals a and I've got x equals b. And I can work out f of a. I can put in x equals a. So that could be the value of, let's say, 1. I could put in 1. I could work that out. And you can see quite clearly that the value I would get would be a negative value. Okay, so f of a here, that would be less than 0. Okay, negative. And then when I worked out, if I sub in x equals b, and I worked out what y would be, you can see that you would get a positive value. So you can say f of b is bigger than 0. Now, if you can see a sign change, okay, over that interval, that means in between there must be a root as long as your curve is continuous. So they might say to you, show that this has a root in the interval a to b. So you'd say, you'd work out what f of a is. You say it's less than 0. You say the other one is bigger than 0. It could be vice versa. And then you say sign change. Sign change. And curve is continuous. So you need to say that the curve is continuous. Therefore, there's a root in the interval a, b. Okay, so here's a question. It says you have got y equals e to the x, that's that one. You've got y equals 2x plus 1, that's a straight line. When x equals 0, and it says it crosses when x equals 0 and when again between 1 and 2. So between 1 and 2 you can see that there is a solution. Okay, so it says show that the equation has a root between 1 and 2. So the first thing you have to do is put this equal to 0. So I'm going to rearrange this to make it equal 0. And then I'm going to work out what that would equal if I subbed in the lower value, 1. So if you sub that in, e to the 1 minus 2 times 1, take 1, you work it out on your calculator, which I seem to have misplaced. Here we go. So I'm going to do that. So I have got e to the 1 minus 2 minus 1 equals, and I've got minus 0.28 something. Okay. And if I do the same with the other value, e to the 2 minus 2 times 2, take 1, work that out. So I'm just going to put that in 2 times 2, and I'll put 2 there. And that, you can see, I get a positive value. So I'm going to say that's less than 0, that's bigger than 0, and then you have to write your statement. So you say sign change, and curve is continuous. And curve is continuous. Therefore, there's a root in the interval well, here in this case, it's 1 to 2. So in between 1 and 2, there's a root. Okay, and on the next screen, I'll show you how to find those roots.